Hi, I'm Daniel Myers, Developer Relations here at Snowflake, and this is another episode of Behind the Data Cloud. Hi, folks. I'm Daniel Myers, Developer Relations here at Snowflake. Today, I'm excited. I'm going to be talking with Ahman Khan all about data science and machine learning on Snowflake and how that can be done, and specifically getting a demo around building a recommendation engine using AWS SageMaker. Ahmad, how are you?
I'm doing great. How are you doing, Daniel?
Doing well. So, I want to first off, learn more about you, your background, and how you got into this space.
I've been with Snowflake for a couple of years, and I'm now in my current position. I'm part of the field CTO team at Snowflake, which is a fancy way of saying like I get to focus on one workload at Snowflake, which is data science and machine learning on top of Snowflake. And before joining Snowflake, I was at AWS for about 5 years, where I focused on their stack of machine learning services, and that's how I got here. And now at Snowflake, it's not just the AWS stack of services. I get to play with all sorts of cool startup products, as well as cross-cloud machine learning products and frameworks as well.
Awesome. So your time at AWS probably means that you have quite a bit of experience using SageMaker.
Yes, absolutely. So at AWS, I was part of like the early betas for the service that eventually became SageMaker. We got the opportunity to present at reInvent about a lot of different higher level AI and machine learning services, such as Amazon Lex and others. So very familiar with their stack of services around machine learning and data science.
Tell me more about the demo that we'll be seeing here today, and I'd love to see it.
Yeah, sure, absolutely. So yeah, this is something that we built last year, and this is after talking to a lot of our customers. They were trying to do and build recommendation systems, right? Recommendation systems are sort of everywhere. If you open your Netflix queue, if you go to Amazon or go to any travel site that you use, right? And it's not just, we think it's all online, but recommendation systems have been around for a while, right? And even in the offline world, we see recommendation systems where you see salsa displayed, placed right next to chips, right? And so I wanted this to be a learning experience for our customers on how to build a simple recommendation engine from a machine learning perspective, but from the perspective of really doing mature ML ops, developing a feature pipeline and developing a framework and a machine learning workflow that lets you do this in a production environment at scale is key. And that's where our customers are struggling. It's hard to take a data science experiment from a notebook and put that experiment into production, right? And you require end-to-end pipelines, feature pipelines that can be very easily implemented at scale in Snowflake. And so it is meant to be educational, as well as it's meant to highlight our integration with world-class machine learning platforms such as Amazon SageMaker. So, going into a little bit in depth here is first and foremost, there are a couple of types of recommendation systems out there, right? And so on the right-hand side, you see content-based filtering. And so in this example, and the data set that I'll be using is an open data set around movie recommendations, right? How do we recommend? Let's pretend we're a streaming service, right? How do we recommend movies to our customers? And so the basic one is I go in and I look at the catalog of my content and all the movies and go and say, okay, this is a horror movie, comedy movie, romantic comedy, whatever, right? And then ask the user what kind of movies they like, and then I can based on their preference, I can recommend like, hey, if Bob likes comedy movies, I can recommend comedy movies to Bob, right? Which is a simple approach, but it does require me to have a lot of historical data about the user, about also the genre information about the movie as well, right? The other one is collaborative filtering, and the collaborative filtering is if I know for a fraction of my users their preferences or their ratings, and so as they start watching movies and they start like giving stars, let's say out of 5 stars, they start giving ratings, I can then find out what the similar users are. And so let's say I have ratings from Alice, and Alice liked these 2 movies. And because I can tell from the data, Alice has similar tastes to Bob, I can then recommend movies to Bob as well. And so this is a very nice pattern where I don't really have to know a lot about my my movie collection, per to say. So in practice, in large scale recommendation systems, what happens is that you have a hybrid recommender, and these are very complicated systems. But today the example that we're going to see is collaborative filtering, and so this is what we're going to see in action. And so the data set that I'm using is a public data set made available by, it's called the Movie Lens data set, made available by Group Lens. And essentially what it is, it's for each user and movie pair, we have either a rating out of 5 or we have a blank question mark, right? And really the purpose of the exercise is to fill in the blanks here, just to be able to say, based on all of these ratings for all these different users, what might be the preference for user 4 for, let's say, Forrest Gump, right? And so we wanna fill in the blanks here with our simple recommendation engine model, right? And so we wanna, and then based off of that, I can recommend the movies, or I can say, hey, just like Netflix, you're 98% likely to like this movie, right? And the way this works with Snowflake is that we underpin the machine learning platform. And in this case, the machine learning platform is Amazon SageMaker. So I can have an end-to-end pipeline where I do all my feature engineering. I can bring in like external data sets from the marketplace to enrich the data. And use this unique capability in Snowflake called external functions, where I can reach out, I can define a function in Snowflake SQL that reaches out to an external API. And so based on that, I can, as new data comes in every day or every hour, I can automate this fully and trigger training jobs automatically that initially train my model, but also retrain my model every hour, every 24 hours, every week, whatever your business requirement is. And then what you're going to see in action today, and the quick demo that I have is really this part, where once I have a deployed model, because this part takes some time, right? Once I have this deployed model outside in SageMaker, how I can leverage external functions within Snowflake to really throw features at it and get predictions back, and then save those predictions in Snowflake. Okay, so let's see that in action. Are you ready?
Awesome. Yeah, I'm excited.
Okay, cool. All right, it's going to be a super quick one. So so if you remember, I just mentioned external functions. So this ability right here to reach out to external REST-based APIs, right? This is a key Snowflake feature that we're going to be seeing. And this is already pre-provisioned. So I have a pre-trained model that's deployed up in SageMaker, right? It's already trained. I can, it's in service. It's this endpoint, right? And I'm going to be reaching out and sending data to it. And to send data to it, all I need to do is create this external function in Snowflake. which is taking a user ID and an item ID, which is essentially a movie ID in this case, right? And it's invoking this endpoint behind which my SageMaker model is deployed. Okay. And so I've already pre-provisioned this, and so I'm going to put in some dummy data into this no ratings table where I have the user ID and the movie ID, where I do not have any rating for that, and my model is going to predict the likelihood that user is going to like that movie, right? And so if we run this, you're already seeing this, but let me just rerun this. And here I see that I've inserted these records. I have the user ID and the movie ID, and then from within Snowflake, I can invoke the model that's deployed at within Amazon SageMaker. So I can run something like this, where I am passing in the user ID and the movie ID, and passing my my data over to SageMaker in a secure fashion. And this deployed model has come back with answers over here, and it's predicting that for user number 1, they're likely going to like heavy metal, and giving it a 4.2 rating, right? And so again, this is really powerful stuff. I can, this is totally composable within SQL. I can package it up. I can, make it as part of a pipeline, run it, rerun it, save these predictions in Snowflake, and then create dashboards or power my data apps on Snowflake.
That's pretty powerful. That's awesome. So, you mentioned a few of the ways that customers of Snowflake and users of Snowflake are using ML in practice today, right? You mentioned, it could be a movie recommendation engine like this. It could be in real tangible items like the chips and salsa. What are mistakes that you find customers making, and how would you solve those?
Yeah, one of that's a great question. One of the interesting ones is that pretty much everybody that's starting out with data science and machine learning will learn how to load data into let's say a Python pandas data frame or an R data frame from a CSV file. And so when they ask for data, they will ask their data engineering team or the data warehousing team to actually export that data into a data lake from where they can actually take that. And that, I feel like, is a bad pattern. You're duplicating the data. You don't have access to the single source of truth, which is your prepared data sets in your data platform or your data warehouse, which in our case is in Snowflake. We give you the optimized connectivity, whether you're using Python or R or even like other systems such as Spark, to reach out and get data directly from Snowflake. You can then push down some of the aggregation, sampling, and a lot of feature engineering into Snowflake, and do that very in a scalable fashion. So you only bring the least amount of data into memory of the training instance, and you can really scale your machine learning training that way.
That makes a lot of sense. So one of the features that we announced back in November, so a few months ago, is unstructured data. How does that fit into a solution like this with Snowflake?
Yeah, absolutely. So we're starting out. So historically, we've been the de facto place for our customers to put in structured data and semi-structured data. Now we have enabled unstructured data. So we're starting out with optimized storage for it. And so you will have the ability to get, first of all, store the unstructured data, that is images, video files, audio files, right? And be able to retrieve it using our REST API interfaces, as well as our SQL interfaces. But over summer, we're going to be releasing new capability where you're going to be able to process unstructured data as well. And as you know, it's in the future, it's all going to be about unstructured data, because all the exciting stuff is happening over documents and images and videos and whatnot. So it's a big priority for us at Snowflake.
Exactly. Yeah, I'm excited for that. So you showed, in your demo using AWS SageMaker. What other tools can be used with Snowflake to do solutions like this?
SageMaker is sort of the default choice for our customers that are in AWS, and for other clouds, there's for GCP, there's AI platform. For Azure, there's Azure ML. But this is an exciting space. There's a lot of very cool startups in this space here. So if I may go back to my presentation, and I think I have this slide here, is you can leverage any of the major machine learning platforms out there, be it the cloud provider first offerings, or very cool auto ML startups such as DataRobot or H2O AI. They don't just provide basic connectivity. There is deep integration that is already implemented, and some of it is coming in the next few months. And for example, in DataRobot, you'd be able to train a model, but with the push of a button, you can push that into Snowflake and then do massive scale bulk inference natively in Snowflake. So very cool features. But I'll add just one thing: no matter what tooling you're using, or whatever language you're using to do your machine learning, the number one reason why some of our largest customers are running data science on Snowflake is the advanced security and governance features that we provide as part of our platform.
That makes a lot of sense. So for our viewers today, where can they go to learn more?
Yeah, absolutely. So the complete step-by-step guide is published at guides.snowflake.com. So definitely check it out. It's not just my recommendation engine, but there's a whole bunch of other very cool labs that you can learn from. That's a really good resource. We have even more code samples in our Snowflake Labs GitHub account to make sure you go ahead and star those repositories there that you like. And then if you have any questions, engage our community. So community.snowflake.com is a great resource that I would encourage everybody to go check out.
Great. And if somebody wants to follow you online, get to know you more, where can they follow you online?
Yeah, search for me on LinkedIn. I'm on LinkedIn, Ahman Khan, and on Twitter, my Twitter handle is kbash09. And I'm not going to answer why that is.
Well, awesome, Ahmad. Thank you for joining me today. This is Behind the Data Cloud. I'm your host, Daniel Myers. Thanks. See you again the next time.